All right, now that we have a better understanding of how our rational exponents work, let's go ahead and just evaluate some expressions. Here we have 32 to the 3/5 power, so we're going to break apart our rational exponent. This is 32 to the 1/5 raised to the third power. 32 to the 1/5 is the same thing as the fifth root of 32. And fifth root of 32 is a common root that we know, or we'll make sure that we become really familiar with these. What number can you multiply by itself 5 times to get to 32? And that is going to be a 2. And then now we can evaluate the power. 2 to the third power gives us a final answer of 8. All right, 27 to the negative 2/3 power. So we're going to break apart our rational exponent. We're going to do 27 to the 1/3 power raised to the negative 2. Let's put that negative with the power. 27 to the 1/3 power, that's the same thing as the cube root of 27. We saw that in our last video, so we know that's a 3. Now, do you guys remember what we do with negative exponents? It's probably been a while since we've worked on these properties, but when you have a negative exponent, it moves to the bottom of your fraction if it's in the top, or if it's in the denominator, it moves to the numerator. When it moves, it becomes positive, and now we can evaluate it. What is 1 over 3 squared? Final answer of 1 over 9. So just look out for those negative exponents. All right, 50 to the 3/4 power. Let's break apart our rational exponent. We're going to have 50 to the 1/4 power raised to the third. Now, that 1/4 power, that's the fourth root of 50. If we think through, 50 doesn't have a perfect fourth root. There's not a number you can multiply by itself 4 times to get to 50. So we can use a calculator to approximate. We could type that in. What is 50 raised to the 1/4 power? And that's a 2.659, kind of a rounded answer. But now we can take that and raise it to the third power. And because it's a little rounded, we'll say we get about 18.8. So decimal answer is okay on that one because 50 didn't have a perfect fourth root that we could take. Okay, so let's apply this to a real life situation because we love these. So I just noticed there's a typo. This is not the fajita scale rating. That should be a U. It's called the Fujita scale rating. All right, and we have it spelled correctly down here, but the Fujita scale rating, F, of our tornado is represented by this, where W is the estimated wind speed of the tornado in miles per hour. What is the Fujita scale rating of a tornado with estimated wind speeds of 100 miles per hour? So this guy over here, how would they rate that tornado on the Fujita scale? So we are going to evaluate this expression for wind speeds of 100. So F equals, we have the cube root of that W, we're going to plug in a 100 for W, divided by 14.1. That is being squared, and we have a -2 on the end. That -2 on the end will be the last thing we do, but let's figure out, oops, there we go, how we deal with this. So here we're taking a cube root, but we're also raising this to the second power. So we can put that back into exponent form. The 100 over 14.1. 2 is the power, 3 is the root, so that's a power of 1/3. So we can rewrite that as our fraction raised to the 2/3 power minus 2. So you can take the root and put it underneath your power, and you're going to get the same answer. Those are equivalent expressions. So now let's simplify what 100 divided by 14.1 is. That gives us, and these are all, we're doing some rounding here, 7.09 raised to the 2/3 power minus 2. That's going to give us that 7.09. If we just type that into your calculator, raise it to a power of 2/3, you get 3.69 minus 2. And then 3.69 minus 2 gives you 1.69. So to answer the question, a tornado with wind speeds of 100 miles per hour is classified as F1 because of the 1.69 according to the Fujita scale.